All right, this video is going to be actually our first time in my class that we look at two sample proportions or two sample tests in general. So this happens when you have two independent groups. There's no dependency between them, and we're looking at successes out of total number of n. So let's say that there are two medication for hives, and they're being tested to determine if there is a difference in the proportions of adult patient reactions. So 20 out of 200 that are given A still had hives 30 minutes after the medication was given, and 12 out of the other sample of 200 still had hives. And we just want to know difference between them. But notice that there are two different medications and there's nothing between them. There's two different populations we're looking at. So A is going to be the true proportion of people who still have hives 30 minutes later with medication A, and B is going to be all of this with med B. And these are two different samples. We have NA and NB are the same. They're both 200, but 20 is our XA, so our P hat. 20 out of 200 would be 10%. And our XB, like our successes here is that they still have hives, right, is 12. So 12 out of 200, 6 out of 100, so 0.06. All right, so I want to test this at a 1% significance level. So alpha in this case is going to be 1, and I just want to know if there's a difference between them. So our null hypothesis is going to be that they are equal, or that PA minus PB equals 0. And our alternative hypothesis is going to be that they are not equal, or PA minus PB is not 0. So I'm going to run a two-tailed test here. And my alpha is very small, like this is 0.005 in each side. So I need like super significant evidence in order to show this. All right, let's go ahead and I'm using proportions, so I'm going to have a z distribution. I'm going to find a p-value, and I'm going to find my critical values as well, and we'll kind of do this whole evaluation once we get our StatCrunch output. So let's go into StatCrunch. When we go into stat and proportions, notice there's this 2 sample right here, and we do have with the summary. So 20 successes out of 200, 12 successes out of 200, P1 minus P2. Make sure that that matches, like that you enter this in the order that matches what you wrote down, and that all syncs up. Otherwise, it's going to do it the opposite way. 0, not equal to 0. Awesome. Yes, show the critical value for me and compute. So Z statistic, okay, is 1.47. So when we do the full equation here, we get 1.47 with a critical value needing to be 1. Oh, you know what I didn't do? I didn't change my alpha level. Let me do this again. Okay. There we go. I need to change that significance right there. Compute. Okay. Critical 2.58. Okay. 2.575 is that critical Z. Plus or minus 2.575. 5. Now this z-score is not going to be in that rejection region, right? Like if this is all the way out at 2.5, 1, 2.5, and I'm here, right? Like I'm not in that rejection region. And what is our p-value? 1404. So that's not less than our significance level. All right, so I'm going to say we fail to reject or do not reject HO. There is not sufficient evidence of a difference in the proportion of hives between the two medications.